Hey guys, and welcome back to another lesson on graphing lines. My name is Miss Danielson, and today we're following the equations of lines. I hope you joined us for our previous lesson on horizontal, vertical, and sloping lines, because in that lesson we went over coordinate points and some of the possible rules that points on a line must be asked to follow. If you missed that lesson, I'm linking it down in the description box so you can check it out before we get started here. If you've already seen it, let's get started. In our previous lesson, we mainly focused on horizontal and vertical lines. For horizontal lines, we learned that the points will always have the same y-coordinate. So their equation or rule is always of the form y equals some number, and you need to figure out what that number is. For vertical lines, we learned that the points on a vertical line always have the same x-coordinate. So their equation or rule always has the form x equals some number that we need to work out. We didn't spend too long looking at sloping lines, so we're really going to focus on those ones today. For sloping lines, what we did learn was that the y-coordinate value will depend on the x-coordinate value. So neither of these values are always the same number. You should hopefully already have these 3 points written down, but if not, take the time to write them down now before we go on to looking at some examples. On a graph, we could have a horizontal line like this, and without too much trouble, you should be able to tell me that the equation of this line, based on its coordinate points, is y equals 2, because you can see that the points that I plotted on that line are 0, 2, 1, 2, 2, 2, 3, 2, 4, 2. They all follow that same pattern or rule that the y-coordinate of each of those points is always 2. Similarly, with vertical lines, you should be able to look at that vertical line and without too much difficulty, be able to tell me what the equation of that line is. Look at the coordinate points I plotted on there for you. That's the point -3, 0, -3, 1, -3, 2, -3, 3, -3, 4, and so on. What's the pattern? What's the rule? The x-coordinate is always -3. For sloping lines, the rule's a little bit more difficult to work out. I left you with this example on our last lesson, and I asked you to try and work out the equation of that line given the coordinate points and the pattern that I hope you noticed with them. If you said that the rule was y equals 2x minus 2, well done. If you didn't write that rule down, don't worry, we'll explain it now. First, let's look at the general format of the equation of a sloping line. That's y equals mx plus c. Whereas you can see from this example, I worked out what the value of m was, and I worked out what the value of c was. When we give the equation of a line in this format, the y-coordinate value depends on the x-coordinate value. That's why we call the y variable in this formula the dependent variable, because its value depends on the x value. So conversely, we would call x the independent variable, because we could substitute any value we like in for x in this formula. As we've seen for this particular line, m is equal to 2 and c is equal to -2. Let's try and figure out what m and c represent by looking at the line and looking at the values we found for it. To understand the equation of a line, we should always start by setting out a table of values. And for that table of values, it's always best to start with the values 0, 1, and 2 for our x-coordinate values. You need at least 3 points to make a straight line. More points are even better so that you can check that the points on your line are following a consistent pattern. So given that the equation of the line is y equals 2x minus 2, if we're trying to find the y value, which depends on what the x value is, if x is equal to 0, as it is for my first coordinate in my table of values, y would be equal to 2 times 0 minus 2, just substituting the x value into the formula. So that would mean y is equal to 2 times 0 is 0 minus 2, which means y is equal to 0 minus 2 is negative 2. So we can fill in our table of value when x is equal to 0, y is equal to minus 2. So now that I have a y coordinate value to go with this x coordinate value, I have an xy coordinate, a point that falls on this line, and that's the point 0, negative 2. X before y, walk before you fly. Let's try and find another point on this line. The next x coordinate value I have in my table of values is 1. So if x is equal to 1, let's substitute that independent variable into my equation of the line to find the value of the dependent variable. What will y be when x is 1? Y would be equal to 2 times 1, I've replaced the x with a 1, minus 2. Now 2 times 1 is 2, so that's 2 minus 2, which is 0. So when x is equal to 1, we found the y value, y will be equal to 0. And now that I have an x and y value that belong together, I've got an xy coordinate. The coordinate 1, 0 will be another point on my line. Let's keep going. We need at least 3 points to make sure this is a nice straight line. So let's go on to our next x value. When x is equal to 2, what will y be? Y will be equal to 2 times 2 minus 2. 2 times 2 is 4, so y is equal to 4 minus 2, which is 2. So when x is equal to 2, y is also equal to 2. We should have a pattern forming here. That's why we need several points to make sure we can figure out what the rule is here. Now that we've got this x and y value, we've got another point on the line, the point 2, 2. Do you see what the rule is yet? If not, let's try another point on the line. When x equals 3, y would be equal to 2 times 3 minus 2. 2 times 3 is 6, so that's 6 minus 2, which is 4. When x is equal to 3, y is equal to 4. And our coordinate point is the point 3, 4. I hope you're starting to see the pattern here because I'm running out of space. Have a look at the first few coordinates we found in our table of values. Negative 2, 0, 2, 4. Do you notice the pattern? From negative 2 to 0, we're adding 2. From 0 to 2, we're adding 2. From 2 to 4, we're adding 2 again. We seem to always be adding 2's. If you look at our equation and our working here, you should see why. We keep jumping by 2's just like the 2's times table. See the multiplications by 2's that we have in our working? 2 times 0, 2 times 1, 2 times 2, 2 times 3. That's because of this 2 here in the equation. The number in front of the x, so the number multiplying by the x, should also match the value that each of our y coordinates seem to be jumping by. So our next y value should be 4 plus 2, that's 6. So the y coordinates and our table of values are just like the 2's timetables. They keep going up by 2's. But the 2's times table starts over here, 2, 4, 6. Why are we starting down here at negative 2? Well, that's got something to do with the c value here. If the c value is negative 2, that's the value that our table of values will start with when x is equal to 0, y is equal to negative 2. In the equation of a line y equals mx plus c, the m value represents the gradient. The gradient of a line is also called its steepness or its slope, and it tells us the rate at which the line climbs up the graph or the number that the y-coordinate seems to jump by. Now, the word jumping is not a mathematical term, but this might help you to understand what the gradient is. This is our gradient. It's what we're jumping by down here. The c value is called the y-intercept, or the y-coordinate when the x-coordinate is equal to 0. So I would say it's the first y-coordinate in my table of values, but that's only if your x values in that table starts with 0. And this is where the line will intersect. Notice y-intercept, intersect. That's where the line will cross the y-axis. So -2 is the value on the y-axis where our line will cross through the y-axis. Let's see that on the graph. Looking at the coordinate points that I've plotted there for you, you should be able to see that they jump up by 2's. Every time I take 1 unit step out to the right, I have to climb up or take the elevator up 2 units to get to the next coordinate on the line. Let's try that again. I take 1 step out to the right, so 1 unit to the right, and I have to rise up 2 units to get to the line again. So my gradient, or my jumping number for my y values, is 2. That's the steepness of the line, and the bigger that number is, the steeper the line will be. My y-intercept should be very clear and obvious. Whenever you see a line graphed, look at where that line crosses the y-axis. This one definitely crosses the y-axis at -2. So that's what gives us the equation of the line. Y equals the jumping number, the gradient, 2x, plus the y-intercept, which in this case is a negative number, and plussing a negative means minusing. So y equals 2x minus 2. Take a minute to copy that down, including the diagram and the note, and make sure it's really clear to you before we go on to the practice exercise. For our practice exercise, for questions 1, 2, 3, and 4, there are 3 things I need you to do. First, I want you to complete a table of values for at least the first 3 points. Remember that we always want at least 3 points to make sure that the line we are graphing is a straight line, not a crooked or zigzagging line. And the first 3 values for x that we like to start our table of values with are always 0, 1, and 2. You can do more values if you like. Next, I want you to list the coordinates that you found in your table of values. When you have an x coordinate and a y coordinate that belong together, you've got the x, y coordinate for that point. Remember to use brackets and to list your coordinates alphabetically. Walk before you fly, x before y. Next, I want you to describe what the graphed line would look like by stating what the gradient is, so how steep will it be, and what the y-intercept is, where will it cross the y-axis. Next, for question 5, using substitution, determine which of these coordinates will not be on the line. Here you've got x and y values that are supposed to follow this rule. Check by substituting the x value into the equation and see if your answer is this y value. If it is, great. If not, let me know. Go ahead and hit pause now, copy these questions, and show your working, and hit play when you're ready to take it up. I hope you had a chance to hit pause, because here come those answers. For questions 1 to 4, let's go step by step. So to complete the table of values, for question 1, when x is 0, y is 0 plus 4, so that's 4. When x is 1, y is 1 plus 4, so that's 5. When x is 2, y is 2 plus 4, that's 6. And when x is 3, y is 3 plus 4, that's 7. Now I've only asked you for the first 3 points, but I've given you 4 points, just in case anybody else has gone on as well. For question 2, for question 3, for question 4. And from those tables of values, we can do part 2 of these questions, that's listing the coordinates. For question 1, 0 and 4 is the coordinate 0, 4. 1 and 5 is the coordinate 1, 5. 2 and 6 is 2, 6. And 3 and 7 is 3, 7. For question 2, 3, and 4, hopefully that's pretty straightforward. For part C of these questions, describing what the graph lines would look like, for question 1, you should be able to see that the y values are increasing by 1 each time. That means that the gradient or steepness of the line is 1. And the y-intercept, that's where the line will cross the y-axis. And remember, the y-axis is the line where x is equal to 0. And for question 1, when x is equal to 0, y is equal to 4. So my y-intercept is 4. Have an idea of what that would look like if these are my x and y axes. Here's my line which crosses the y-axis at positive 4, and it is going upwards with a steepness of 1. Now that's just a sketch, so you can't see exactly what those numbers are, but you can see that the line crosses the y-axis at some positive number, not too far from 0, and the line is sloping upwards, not too steeply, but also it's not a horizontal line. For question 2, you should see that in the table of values, the y values are getting more negative. That is, they are going down in values, and they're going down by 1s. So the gradient of the line will have a steepness of -1, and the line will cross the y-axis when x is equal to 0, y is equal to -3. The y-intercept is -3. To get an idea of what that might look like, here is my x-axis and my y-axis, and you can see that my line will cross the y-axis somewhere in the negatives, not too far from 0, but definitely below the point of origin. And this line is sloping downwards as we go across. It's not too steep, but it's definitely not a horizontal line. It's a steepness of -1. For question 3, you should have noticed the pattern in the table of values. -6, -2, 2, 6. Those numbers are getting bigger, and they're jumping up by 4s. So the gradient of the line in question 3 is +4. And the y-intercept, this line will cross the y-axis where x is equal to 0, y is equal to -6. So a sketch of that to show you what that would look like. Here's my x-axis and my y-axis, and this line will cross the y-axis definitely down in the negative numbers, quite a bit further from the point of origin than the previous question. This here's -6, and the line is rising with a steepness of 4. Note that that's steeper than a steepness of 1. For question 4, you should notice in the table of values 2, 0, -2, -4. The y values are going down by 2s. That's a gradient or steepness of -2. And the y-intercept, the line will cross the y-axis when x is equal to 0, y will be equal to 2. So a sketch of that graph might look something like this. As you can see, my line is crossing the y-axis up in the positives, not too far from 0, but +2, and it is sloping downwards with a gradient of -2. Now, of course, for all of these descriptions, you could also just look directly at the equations of the lines. A gradient of 1, because there's 1x. A y-intercept of 4, because we're plussing 4. A gradient of -1, because this is -1x. And a y-intercept of -3, because we're subtracting 3 here. A steepness of +4, this is +4x, and a y-intercept of -6, because we're subtracting 6. Finally, a gradient of -2, because this is -2x, and a y-intercept of +2, because we're adding 2 here. On to question 5. Which of these points do not belong on the line? I hope you didn't just guess. Using substitution, substituting the x value into the equation of the line, When x is equal to 0, y will be equal to negative 3 times 0 minus 7. I'm just replacing the x value with 0. That's going to be 0 minus 7, which is negative 7. So the point 0, negative 7 is on the line. If x is equal to negative 3, substitute that into the equation. Y equals negative 3 times negative 3 minus 7. A negative times a negative makes a positive, so that'll be 9 minus 7, which is 2. The point negative 3, 2 is on the line, not negative 3, negative 7. So that one's wrong. If x is equal to negative 1, y will be equal to negative 3 times negative 1 minus 7. Again, negative times negative is positive. That's going to be 3 minus 7, which is negative 4. So negative 1, negative 4, that's correct. That is on the line. Next, if x is equal to positive 1, y will be equal to negative 3 times 1 minus 7. That's negative 3 minus 7, which is negative 10. So the point 1, comma, negative 10 is on the line. Be very careful with your signs here. These coordinates may look the same, but 1, comma, 10 is not the same as 1, comma, negative 10. Finally, if x is equal to 2, y will be equal to negative 3 times 2 minus 7. That's negative 6 minus 7, which is negative 13. So the point 2, comma, negative 13 is on the line. Just to make our answer really clear, the points that are not on the line are negative 3, negative 7, and 1, positive 10. So how did you do? Hopefully that was fairly straightforward, but I can understand some people tend to have a difficulty with this. Please let me know down in the comment section if you have any difficulties or doubts that I can help clarify. Otherwise, well done, keep practicing, and I'll see you soon.